There is so much out there beyond Earth. You can never truly completely discover the wonders of this amazing universe. Have you ever heard of a parallel universe? Many famous scientists have been giving theories about it, including Stephen Hawking. So what did scientists actually say about it? What exactly is a parallel universe? And why is this discovery so shocking for all of us? Hey everyone, welcome to Space Scientists. In today's video, we are going to talk about first ever parallel universe has finally been discovered. So, if you want to know more about it, then stay with us until the end of the video. And before we start the video, don't forget to like this video, subscribe to our channel, and ring the bell icon for more amazing videos. For some of us, the idea of parallel universes sparks our wildest dreams. If there are other universes where certain events had different outcomes, where just one crucial decision went a different way, perhaps there could be some way to access them. Perhaps particles, fields, or even people could be transported from one universe to another, enabling us to live in a universe that's better in some ways than our own. These ideas have foothold not only in science fiction, but in theoretical physics as well. From the infinity of possible outcomes from quantum mechanics to ideas related to the multiverse. But do these ideas have anything to do with observable, measurable reality? Recently, a claim has surfaced asserting that we found evidence for parallel universes from the Antarctic Impulsive Transient Antenna, or ANITA. It's true. The experiment found evidence for cosmic ray particles that's quite difficult to explain using only conventional physics. But to leap to the most fantastical, outlandish, revolutionary explanation is absolutely premature. In all fields of science, we have to take tremendous care not to fool ourselves. We must endeavor to knock down any new, wild hypotheses and instead make sure that known laws of nature can't conceivably explain what we're seeing. Parallel universes first arose in the context of quantum physics, which is notorious for having unpredictable outcomes, even if you know everything possible about how to set up your system. If you take a single electron and shoot it through a double slit, you can only know the possibilities of where it will land. You cannot predict exactly where it will show up. One remarkable idea, known as the many worlds interpretation of quantum mechanics, postulates that all the outcomes that can possibly occur actually do happen, but only one outcome can happen in each universe. It takes an infinite number of parallel universes to account for all the possibilities. But this interpretation is just as valid as any other. There are no experiments or observations that rule it out. However, while some scientists dismiss this theory as fiction, more proof is coming in about the existence of these alternate universes. Yes, it's not the first time somebody has thought of the possibility of the existence of parallel universes, but recent evidence have led to scientists exploring their options while they try to find a concrete explanation for them. In the discovery that was made in Antarctica, they feel right out of a sci-fi plot hole. NASA has detected substantial evidence which could be one of the first ever practically unexplainable events that suggest the existence of a parallel universe, where time moves backwards and the rules of physics are contrary to ours. By now, it is very clear that our Earth is a very minute existence in the cosmos, and in spite of all the knowledge humanity has gathered, it is still discovering new revelations every now and then. Sir Isaac Newton rightly said, "What we know is a drop, what we don't know is an ocean." The concepts of parallel universes is something that looks as if it's right out of movies or fan fiction, but has certainly aroused the curiosity of viewers and readers everywhere. The idea of existence of parallel universes was first conceived by a Princeton University student, Hugh Everett III, back in 1954. In his theory, he wrote about the possibility of parallel universes, or universes that look exactly like and are related to our existence, that branch off from ours. This theory, known as Everett's many worlds theory, was one of the most plausible attempts to answer the numerous unanswered questions raised by quantum physics. Everett's approach of this theory contradicted many of the currently accepted laws of physics, and it made many scientists uncomfortable. The thought that the outcome of an event could have been different in another universe at every different time juncture, even having differences as drastic as life and death. Multiverses and parallel worlds are often argued in the context of other major scientific concepts like the Big Bang, string theory, and quantum mechanics. That mysterious process of inflation and the Big Bang have convinced some researchers that multiple universes are possible, or even very likely. According to theoretical physicist Alexander Vilenkin of Tufts University in Massachusetts, inflation didn't end everywhere at the same time. While it ends for everything that we can detect from Earth 13.8 billion years ago, cosmic inflation, in fact, continues in other places. This is called the theory of eternal inflation, and as inflation ends in a particular place, a new bubble universe forms, Vilenkin wrote for Scientific American in 2011. These bubble universes can't contact each other because they continue to expand indefinitely. If we were to set off for the edge of our bubble universe where it might butt up against the next bubble universe over, we'd never reach it because the edge is zipping away from us faster than the speed of light and faster than we could ever travel. But even if we could reach the next bubble, according to eternal inflation, our familiar universe, with its physical constants and habitable conditions, could be totally different from the hypothetical bubble universe next to ours. This picture of the universe, or multiverse as it is called, explains the long-standing mystery of why the constants of nature appear to be fine-tuned for the emergence of life, Vilenkin wrote. He further added, "The reason is that intelligent observers exist only in those rare bubbles in which, by pure chance, the constants happen to be just right for life to evolve. The rest of the multiverse remains barren, but no one is there to complain about it." Vilenkin's explanation implies that in some of the infinite bubble universes outside of our own, there could be other intelligent observers. But in every instant that passes, we get further away from them, and we will never intersect. Some researchers base their ideas of parallel universes on quantum mechanics, the mathematical description of subatomic particles. In quantum mechanics, multiple states of existence for tiny particles are possible at the same time. A wave function encapsulates all those possibilities. However, when we actually look, we only ever observe one of the possibilities. And this is it for today. What are your thoughts on today's video? Share your views with us in the comments below. Also, don't forget to give this video a thumbs up, subscribe to the channel, and ring the bell icon for more amazing videos about space. And thank you for watching.